Hello, everyone. My name is Jolanda Verhoef, and I am a developer relations engineer on Android, focusing on AI. I am happy to be here to talk to you about how you can build intelligent Android apps using Gemini. Now, this isn't just any other product cycle. We are entering the next era of mobile. And I personally really think that this is a very exciting and transformative moment for us as Android developers. Earlier today, you already heard how AI helps basically change your day to day programming experience. But I will walk you through how you can actually implement AI use cases in your Android app. But first, let's set the stage for this new mobile era. We stand at a unique crossroads. We kind of have an opportunity to transform the way that we use our phones today. The way that users interact with their devices is changing fundamentally, and it is all driven by rising expectations and breakthroughs in AI. And this is what we're seeing. Our users now expect personal, intelligent, and agentic experiences on their mobile devices. And to meet this, Android apps should provide intelligent experiences that enable personalized, helpful, and truly delightful interactions. It is all about being proactive instead of reactive. So, when we look at the AI landscape, we see an explosion of all sorts of use cases. And we've categorized them into three major areas. So first we have the helpfulness section, which is like things like contextual AI assistant or proactive spam and fraud detection. Second, we have content, including everything from summarization and classification to creation and editing. And finally, we have social and communication, which is where we see kind of the true visual magic, like image generation, editing, and even super resolution zoom. Now, Google is positioned quite strongly into this new AI world. We have been investing in AI for over a decade, and today we stand firmly in the Gemini era, with our latest and most capable model, 2.5 Pro, leading the way. And this investment allows us to offer you, the developer, unparalleled power. Now, the key to enabling these advanced use cases and all that power is that we have an end to end stack. So we have a vertical integration across both cloud and services, and that allows us to innovate faster. So we have a variety of tools, and those tools handle the deep optimization for you. It is more secure because we have built in end to end security measures, and it is seamlessly tuned to interact and work well together, giving you this kind of like instant magical performance. Now we have a wide range of developer tools and offerings. First, AI Studio lets you prototype with the models, so you can actually try them out very easily without a lot of effort, without having to actually build them into your app and actually access the APIs and all that. It's just an easy way to access any models that you want. Then we have a powerful model suite that spans Gemini, Gemma, but also Imagen models. And we have a rich set of SDKs, which include the Kit GenAI APIs SDK. I know it's a mouthful. For on-device tasks, and we have the Firebase AI Logic SDK for our cloud inference. And to bind it all together, we have an AI sample catalog on GitHub that you can use to see all kinds of reference implementations of common use cases using these SDKs. So without further ado, let's get started on how you can actually build your intelligent app. When you are deciding on the right approach for your app and your use case, there's a whole lot of different factors that you're going to have to consider. And I've outlined them here. So we have the context window, which is basically the amount of data that the model can process, the device reach, or which devices can actually run the model, the complexity of the task, but also offline availability, the cost associated with the money, modality of the data, and whether or not it is doing local processing. So let's first look at context window complexity and modality. First, you can think about modality and thinking about what is it that you are feeding into the system. Is this text and images, or is it something more complicated like audio and video? And then you also, of course, have to consider what comes out of the model. So are you outputting text or are you doing image generation? you can look at the complexity, which is basically like, what do you want to do? Is it a kind of common task, like things like summarization or proofreading? Or is it something way more complex, like requiring domain logic, for example, something in the financial world or the medical analysis, etc.? Then third, we have the context window, which is basically like the amount of information that you need to pass to the model at a given point in time. So are you analyzing short input and output, or do you need much more like extensive documents or hours of audio and video? Now, if you're all in the white boxes here, then on-device GenAI might actually be a really good choice for you using Gemini Nano. However, if you're more in the kind of gray boxes, in the gray areas, then it's quite probable that you want to look at the Firebase AI Logic SDK, which runs the more powerful models in the cloud. So besides model capability, there are also some other considerations. We have on-device inference, which of course means that your AI is available offline, which sometimes is a really good choice for a use case. It processes your data locally, which is great for privacy, of course, and it has no inference costs. However, it is generally less capable than the cloud inference. On the other hand, cloud inference offers our most capable models and is available on any connected device. But of course, it requires network connectivity and it will incur inference costs. It also has more modalities than you have on device, and the cloud models have a very large context window. So it's really up to your use case to decide if you're going to do on device or if you're going to do clouds. So let's take a look at all the models that we have available. On the one hand, on device, we have Gemini Nano and we have Gemma 3N. Now, both of these use the same architecture, but Nano is pre-installed on many of our flagship devices and it is integrated into the system. While Gemma 3N is an open model, and that makes it great for experimentation. So you can use it, for example, in AI Studio. But again, they're using the same architecture. So it's easy to experiment with Gemma 3N and then go to production with Gemini Nano using the same prompts. Now, after looking at on-device, we will continue with the cloud inference. And we'll look at Gemini Pro and Gemini Flash. But also we'll look at image generation and image editing using the models Nano Banana and Imagen. So let's start with the on-device bit here. Now, I know that on-device kind of might sound like kind of a far thing into the future, but we actually already have many Google apps that are leveraging Gemini Nano in production today. For example, we see summarization in Voice Recorder, we have smart replies in Gboard, and we have image descriptions automatically created in Talkback. Beyond that, we have Nano powering features like personalized weather summaries, but also on-device scam detection, doing automated things with screenshots, but also summarizing your calls and taking notes. So these are all already productionized real-world examples, and we are now actually bringing all that capability to you, our developer community, as well. So how do you get started? Well, as I said, we have the Kit GenAI APIs, and that is actually quite straightforward. So we launched with this subset of common use cases that, you can kind of apply to almost any app or any situation. We have summarization, proofreading, rewriting, and automatic image description. So these APIs abstract away the complexity of the model, allowing you to integrate core GenAI features using minimal codes. So when I say minimal code, let's take a look at the code, right? So you can see here, how many lines of code is it? I think it is 9 lines of code, and I even did like extra returns in the beginning. So you can see how easy this is, and you don't have to do any API calls yourself. You don't have to do any LLMs, any prompting, etc. The only thing you're doing is you're creating a summarizer client first. You specify the input type, the output type, and then you get a summary as a result. It's just that simple. However, as I said, it is a limited set of use cases, right? And so what if your needs are more specialized than that? So what if you want to go beyond our feature-specific APIs? This leads us to the next more flexible tool in your toolkit, which you already heard about this morning. For anything that requires more flexibility, we are launching the Kit GenAI Prompt API. This is the lower level API that allows you to send natural language directly to Gemini Nano, which supports both text and image inputs, and then it will provide text output. This is basically your creative canvas to create whatever bespoke on-device experience you want. So again, the code demonstrates the ease of use. You can see how easy it is to basically create an image and a text as inputs. And then also you can basically configure what you want, for example, the maximum output tokens to be, or what you want the temperature to be, all these kind of like prompt configuration things. So one example that we have is that we partnered with Cacao Mobility, and they are already using this new prompt API in production. So you can actually take a look and you can actually start using this. They use it to basically get a natural language chat message and then extract the relevant information from it. So the prompt API unlocks a lot of use cases. In image understanding, you can analyze photos for classification, or you can perform intelligent document scanning for expense categorization. Then for creative content, it offers inspiration and brainstorming. And for content analysis and entity extraction, you can label user reviews, automatically tag nodes, or extract names and addresses from text. Basically, this is the ultimate tool for the use case that you need. But then that actually raises a question, right? Because if we have that great prompt API that we want everyone to use, then why would you still use these feature-specific APIs that I mentioned? Well, the feature-specific APIs basically have a prompt that is generated by us, by Google. And that makes them typically faster, more reliable, and pre-configured. So if you have a use case that matches one of those predefined ones, you're probably better off just using that and kind of utilizing the fact that we did all the testing, we did all the optimizing, etc. However, then if you have a use case that doesn't fit the mold, it might be better to look at the Open Prompt API. So to quickly summarize, basically what we're looking at is this divide, this trade-off. On the one hand, we have speed and ease, and then on the other hand, we have high customization. Our feature-specific APIs allow for basically a low integration efforts, but they are limited. So even if you do summarization, for example, you're going to be limited to 1 to 3 bullet points. Or if you create an image description, this image description will be relatively short and generic. On the other hand, our prompt API is more complicated and more customizable, but it does mean that you're going to have to do the prompt engineering, which for an on-device model is going to take you some time, and you're going to have to do your own quality assurance, making sure that your use case performs well. So with that, I think we can move to cloud inference. So why would you move to the cloud? I think we've handled quite a lot of reasons, and basically the core of it is it's about capability and scale. So if we look at the core of our cloud offering, we have basically the Gemini model suite. We have Pro, which is our flagship model for your most complex reasoning and long context tasks. Then we have Flash, which is more of the workhorse model that you would often use if you want to have a good price performance ratio for our high volume, low latency tasks. But also don't forget Flash Lite, which works really well if you are on a budget because it is typically cheaper. So how do we access these models? Well, there is two API providers that you can use. On the one hand, we have the Gemini Developer API. On the other hand, we have the Gemini API in Vertex AI. So you would use the Gemini Developer API when you're getting started. And it makes it really easy to kind of iterate using Google AI Studio. It also has a generous no-cost quota, which is quite nice, and allows for smooth upgrades the moment your user base starts scaling. However, the Gemini API in Vertex AI is great if you have more of an enterprise-grade solution. So if you're already in the Google Cloud ecosystem, for example, it's quite easy to move into this solution as well. And it offers critical availability, scalability, and control over your inference location, which, especially here in EMEA, can be an important thing. So how do you access these two APIs? Well, actually, there's two ways in which you can do that. First of all, you could create your own service layer, right? You create your own backend. Your mobile app talks to that backend. The backend has the API key of that API. And so the backend does the call and then returns the result to the mobile app. Now, that works, but this means that you're going to have to build and maintain and host and do all of that for that service layer. So this is why we have introduced Firebase AI Logic, which kind of handles all of that for you and much more. So the diagram on this slide shows how the Firebase SDK kind of intermediates between your mobile app on the one side and then the APIs in the cloud on the other side. And it's great because you can actually just call this Firebase SDK using simple Kotlin codes. So let's take a look. Again, not that many lines of code. We import the right Firebase dependencies. Then we create our model. So in here, I am saying that I want to use the Google AI backend, and I'm going to use the Flash model running in it. And then I call the generate content method, and I get my response. It's as easy as that. Now, as you could see, that already takes away from like having to do your own REST API call. So that's quite nice. But there's some extra benefits here as well. So Firebase has something called app check that is built into the system and the SDK, which prevents abuse from illegal basically requests from other apps or when your app is tampered with, etc. So this makes sure that it's really your untampered app that is doing the call to the AI system. But also we have remote config built into Firebase, and that plays really nicely with this system because the best AI features actually require constant tuning. You might actually want to update your model name, like maybe you want to downgrade or upgrade based on what you see happening in production. You might want to change the generation parameters and tune those, or even change the actual prompts that you're using. And all of this is possible if you use remote config without having to do any sort of new app release, which is quite nice because you can get like the latest model to a beta segment of your users, or you can swap to cost-efficient models if you need to. Then if your use case involves large multimodal inputs, for example, images, PDFs, and video, and if you're using the Vertex AI API, you can accelerate uploads by using the cloud storage for Firebase. And this ensures that your data pipes are as fast and efficient as your models. And finally, once you actually go to production, you of course want visibility. Now, AI monitoring gives you access to powerful tools within the Firebase console so that you can understand key metrics like requests, latency, errors, and token usage. But then also that ties into usage and expenses, right? We want to know how expensive it is to run these models. And the tools in Firebase and Google Cloud give you the financial visibility that you need to keep your scalable services running efficiently. So to summarize this, basically we, with the Firebase AI Logic SDK, we have created an easy way for you to add generative AI to your mobile app and publish it in production. Now, next up, I would like to focus on some newer capabilities that we can use with our cloud models. So far, we've mostly looked at kind of like text-based and general purpose GenAI. But what about our visual experiences? So let's talk about kind of a creative area, image generation, using Nano Banana and Imagen. And this is where our models turn text prompts into stunning visual realities, and they transform user engagement through customization and personalization. The use cases for this visual power are quite wide, right? They all center, though, on one critical theme, increasing your user engagement through personalization and customization. So imagine that you can generate contextual artwork for your unique app events, allowing your users to create highly personalized user profile avatars on the fly, or you can let them design their own custom stickers based on a simple text prompt. These are the kinds of magical experiences that really can move the needle for your adoption and retention. Now we have two primary engines for image generation, and each is optimized for different needs. On the one hand, we have Gemini 2.5 Flash Image, which is the one that we all so much like to call Nano Banana. And it brings Gemini's world knowledge and reasoning capabilities directly into your image generation pipeline. So you get more contextually relevant images. And importantly, it also allows you to edit images in a conversational style, and it maintains context throughout that interaction. So it's uniquely suited to embed accurate visuals within long, complex text sequences. Next up, there is Imagen, which gives you greater control over the aspect ratio or the format of the generated images. And it also gives you this kind of like control over the details. So what we see is that the Nano Banana model is really great if you want to have this kind of sparring partner to talk to and actually like iteratively edit an image. But then if you want like more highly specific editing features and generation features, Imagen is kind of like helps you a lot more. So both of those have their own value and you can choose what works for your use case. So the best way to actually understand what that means for you is to go to AI Studio and to try them out, right? It is really like I would really recommend this, like see what you can do with it, see if this works for the use case that you can have in your apps. So how do you access these powerful models from your Android app? Well, I already discussed that we have Firebase, and Firebase is great for intermediating. So I can show you how we can use the Firebase AI Logic SDK to easily and quickly access these models. So let's start by looking at chatting with Nano Banana. Here I'm showing a sample from our sample catalog, where I'm basically asking the AI to generate an image of a dog working as a chef. Cool. Okay. It will do that and it will come up with this great image. And then I can conversationally replace, for example, all the healthy stuff that is on this chef's plate and say, well, actually, can you just replace all of that with meat? And this is all done directly in a sample with just a few lines of code. So let's look at the lines of code, right? We would start with configuring the model using the Flash image model that represents Nano Banana. And we allow the model to respond both with text and with an image. Then we can start a chat session with this model. So we use the model.startChat method, and we send the initial query, generate an image of a dog working as a chef. Now, after that initial image is received, we can just parse it from the results, and then we can continue. We can send another message and say, replace the vegetables with meat. And as you can see here, I did not have to like send that image again. That is all handled by my chat session. And finally, we're parsing the final image. That's all we need. Now let's look at Imagen next. So as I said, Imagen is very powerful and very strong, not only for image generation, but also for image editing. So one feature that I would like to show you today is how you can use Imagen to do mask editing. So here we have another dog as another chef, but I kind of don't like the fact that it is using pancakes here. I'm not really a big pancake fan. And so what I can do is I can actually draw a mask and that will force the system, force Imagen, to only replace pixels within that mask. So it gives us much more control over what the editing actually can and cannot do. And so here I'm adding a prompt and I'm saying remove the pancakes and add an omelette. And as you can see, like the rest of the image stays exactly the same. There is no way that that can actually change. And here we're doing kind of like in painting, we call that, where you have a mask and that's where you allow pixels to be drawn. But you can also use things like out painting to kind of expand the size of the image, etc. So how we implement this is that we set our backend to Vertex AI. And we set our model to the Imagen 3.0 capability 001 model. That's the one that supports this editing. Then we call the model's edit image methods with our original prompts and with the original image and with the mask. Now, of course, we have to have UI code of drawing that mask, etc. That's all part of the sample. It's a little bit too much to show here. But as you can see, the actual code to execute is still relatively small. So one more feature that is relatively new that I would like to show you and that we recently added to the Firebase SDK is low latency real-time voice and video interactions using the Gemini Live API. And here I would like to get started using a demo. So let's go. Hi there, can you add buy milk to the list and remove read a book?
Okay, I have removed read a book and added buy milk to your to-do list. Is there anything else?
Yes, can you check off buy bread and buy eggs, please?
I have checked off buy bread and buy eggs from the list. Anything else?
And as you can see, what we're using here is we're using the AI as kind of a voice control. So instead of having to do anything in the app ourselves, what we can do is we can just have a natural conversation with our AI system and let it do the actions for us. Now, that is only one thing that you can do with Gemini Live API. There are all kinds of different use cases like voice search or a sort of a reading mode or questions and answers, etc. And so, how do you actually implement that? Well, first, we again configure our model. So, we use the Gemini Live 2.5 Flash preview here. And as you can see, it has a preview postfix suffix, which means that this is a preview model. So, it can still behave in ways that you don't expect. And this is not something we would consider production ready at the moment. What we then do is we tell it to respond to us using audio and we give it a system instruction. So at this point, we're saying this is what you should be doing so that we can then actually start the audio conversation with that context in mind. Now, this works and we will be able to talk back and forth, but that doesn't mean that that system can actually now do things in my app, right? Like we need to add some code so that it can actually add things to the list, remove them, or check them off. So that's something that we call function calling. So function calling is a principle where we define custom Kotlin functions and we provide those to the model so that the model can call them. Now, there are several different reasons why you would want to do function calling. For example, you can use it so that the model can request certain information about the world, like augment its knowledge, but also it can interact with your app, for example, to retrieve the user profile or like navigate throughout the app. And this is also where the kind of like adding and removing comes from. And so what happens is that when we call the Gemini model, and this actually goes for any Gemini model, this isn't just the Gemini Live API that has this functionality. Instead of just sending the prompt over, what we do is we add a sort of a toolbox. So we add a set of functionalities that, you've seen in the talk before as well, that the LLM can call. And then it can choose to do one of those function calls and then finally return a model response. So if we look at the implementation, what we do is we start by creating a thing called a function declaration. And so here in natural language, we describe what that function is and what it can do. So in this case, we're saying, we have a function called add list, which is the function that adds an item to the list. And it has a parameter, which is the actual to-do item. Now, when we create the model, we can add our set of function declarations here. In this case, I'm just adding the add list for brevity. And finally, when we then actually get a response, we have a function call handler, which basically has a big switch and goes through the different types of functions, and it actually does the function call for you. So this still, you actually need to implement the actual function call yourself. Now, with function calling, we basically give the model eyes and ears because it can retrieve information from us, but we also give it kind of like hands and feet, like we make it actionable. And that is quite cool and quite fundamental. And once you start thinking about what that could do in your app, I think you will find really good use cases. And if you do, I'm very interested in hearing them as well. So with that, we are done, but I do want to summarize what we've handled today. So we focused on using two different SDKs, an on-device SDK on the one hand and a cloud SDK on the other hand. The Kit GenAI APIs SDK helps you to run inference on the Android device using pre-optimized use cases, or now also with open prompting. Alternatively, on the cloud, we can use Firebase AI Logic SDK, which opens up access to the various Gemini models, but also building image generation and editing with Imagen and voice and video using the Gemini Live API. So with that, I would like to point you to our resources. The top one is our landing point for all things AI on Android. And then the other one is the sample catalog that I talked to you about. With that, thank you so much and have a great day.